Hello everyone, I am Dr. P.K. Hota. In this introductory video, I will explain different type of organic reactions. If you go to any organic chemistry book, you will find numerous name reactions. But believe me, all these name reactions one can classify it into four categories. One is substitution reactions, second is addition reaction, and third is elimination, and fourth one is pericyclic reaction. So all these reaction is based on these four type of reactions. Now first one is substitution reaction. In substitution reactions, what happens, this attacking reagent when attack this reactant, some part of this reagent is replace one atom or group of atom of this reactant. So it is replaced and a new product is generated as shown in the figure. So basically, based on this nature of this reagent part, whether it is nucleophile or electrophile or free radical, based on this one can say it is nucleophilic substitution reaction or electrophilic substitution reaction or free radical substitution reactions. For example, here, if the part of the reagent is a nucleophile, negative charge, attack the reactant, then we have a product after replacement of this X group from the reactant. Then we call it a nucleophilic substitution reaction. Similarly, if the positive part of the reagent attack the reactant and replace one part of the reactant, one part or group of atoms, then we call it a electrophilic substitution reaction. Now more specific example is that if we treat any alkyl bromide with aqueous potassium hydroxide solution, then the negative part of this hydroxyl group will attack this carbon attached to the bromine, and this bromine is replaced. The bromide ion is replaced and we have an alcohol. So this is a nice example of aliphatic nucleophilic substitution reaction. Of course, this reaction is further divided or classified into different categories like SN1, SN2. This is nothing but unimolecular. One means unimolecular, two means bimolecular, and substitution nucleophilic reaction. This in detail we will discuss in my second video. But in this introductory video, I will explain only different types of reaction. That is four types of reaction. This is another example. If the nucleophile attack the aromatic compound with a leaving group, then the nucleophile attack this carbon because this is more electrophilic in nature and X is a electron withdrawing group, so it is highly deficient system. So this nucleophile first attack this carbon, and in this way a rhenium ion will generated, and this rhenium ion, negative charge ion, is stabilized through various resonating structure, and later on in the second step, after the depart of this negative charge electron withdrawing groups, we will get the final product. So this is also an example of nucleophilic substitution reaction. Now second type of reaction is the addition reaction. In addition reaction, what happens, all the part of this atom or group is added to the reactant and we have a new product. So generally this type of reaction one can observe in compound which have a multiple bond like olefin, alkyne, carbonyl, nitrile compounds. And similarly, depend upon the attacking groups, one can classify it further this addition reaction into electrophilic, nucleophilic, and free radical type addition reaction. Now, this is a nice example of electrophilic addition reaction. If you take a olefin and add to hydrogen bromide, now this olefin is electron rich center. So this olefin electron will attack the electron deficient part of this hydrogen bromide, and in this way the bromide ion is separated and a carbocation is generated. And in the second step, the bromide ion will attack this positive charge to get the bromoalkane. So this is a nice example of electrophilic addition reaction. Now another is free radical addition reaction. When free radical initiate the addition process, we call it free radical addition reaction. Like the same olefin react to hydrogen bromide in presence of a peroxide. The peroxide, if we irradiated light or sunlight or any UV visible light, so this peroxy compound will generate peroxy radical, and this peroxy radical react with hydrogen bromide to generate a bromine radical. This bromine radical now initiate the reaction. It added up the olefin, and we have two types of radical generated. One is branch position, the radical is generated at the branch position, and the radical as the terminal carbon. So terminal carbon is less stable and the branch carbon is more stable because of hyperconjugation effect. So we will in the next step, this radical, this alkyl radical will react with hydrogen bromide to give the bromo product. So this is a nice example of free radical addition reaction. Similarly, we have nucleophilic addition reaction. Mostly this kind of reaction takes place in carbonyl compounds. Now the third type of reaction is the elimination reaction. In elimination, what happens when the attacking reagent attack the reactant? Now two part of this reactant, okay, eliminated. Like here, two part is eliminated in presence of reagent, and a new product is generated. So this is basically takes place in presence of a base. So this is the nice example of alpha, beta, gamma elimination reaction. If the chloroform, if we treated chloroform with potassium hydroxide, then a carbon intermediate is generated. Here, the hydrogen and chlorine, two groups are eliminated from the same carbon atom. So we call it alpha elimination or 1,1 elimination reaction. In another example, if a alkyl bromide treated with potassium hydroxide, if one group from one position and second group from two position is eliminated, then we call it beta elimination or 1,2 elimination reaction. Similarly, if two groups are eliminated from 1 and 3 position in presence of potassium hydroxide, a base, we have a gamma elimination or 1,3 elimination. In this case, we have a cyclopropane is the final product. In 1,2 elimination, we have olefin is the final product. So based on the nature of attacking reagent and the elimination group, this reaction also classified into unimolecular E1, bimolecular E2, and unimolecular from conjugate base E1CB type elimination reaction. We'll discuss this in the coming next video. So this is quickly I'm explaining what is happening in E1. In E1, the first this leaving group with in presence of a base, it departs and a carbocation ion is generated. And in the second step, the attack of base upon this hydrogen or proton is removed by the base, and we have a olefin compound. So the first step is the slow step, is the rate determining step, and this reaction is unimolecular. The rate of reaction is depend upon the substrate, and polar solvent increase the rate of reaction because the carbocation is stabilized in polar solvent. Similarly, we have E2 reaction. In E2 reaction, the base attack the proton directly, and simultaneously the leaving group departs to get the olefin compound. So here there is no intermediate structure generated, and the non-polar or aprotic polar solvent accelerate the rate of reaction, and the rate of reaction depend upon both base and alkyl bromide. Similarly, E1CB, here in case of this, in presence of base, the proton is removed in the first step, so it is a first process, and a carbanion ion is generated, which later on replace this leaving group to generate the olefin compound. The last type of reaction is the pericyclic reaction. These reactions are also called concerted reactions because of a one-step reaction via a 4 or 5 or 6 member transition state. This reaction follow the molecular orbital theory in which a reactant, generally olefin, butadiene or hexatriene, and the reagent is a dienophile, a olefin compound, overlap to give a cyclic compound. So also this pericyclic reaction is either electrocyclic or cycloaddition or sigmatropic rearrangement. So this is the example of cycloaddition in which the butadiene interact with the olefin compound through thermal reaction and generate a 6-member transition state, which later on generate the cyclohexene derivative. Similarly, electrocyclic reaction in which this butadiene through photoreactions it generates a cyclic 4-member transition state, which later on converted the product cyclobutene. And this is the third one, 1,3 sigmatropic rearrangement reaction in which the allyl compounds rearrange via a 4-member transition state to generate a rearranged product. So the hydrogen is shifted from one position to this 3 position. Though these compounds are very similar compounds, same molecule, but if you put here a substituent, then we have a completely different product. So overall, we have discussed inorganic reaction, though there are many organic reactions, but all these reactions can be classified into 4 categories: substitution reaction, addition reaction, elimination reaction, and pericyclic reaction. And depend upon the type of attacking reagent, substrate, and the intermediate structure formed during the reaction, the rate of reaction and the yield is highly depend upon these four factors: substrate, reagent, solvent, or intermediate. So in my next video, I will explain each reaction in detail. Thank you.